Hello guys, welcome to the Adroit Things. Okay, let's get straight into it without any dilly-dallying. Okay, so today I'm going to talk about how to make a vector perpendicular to another vector. I want to talk about this because it's one of the basic concepts that exposes many underlying things that are very essential when getting into game development. Yeah, so just bear with me. Okay, let's get straight into this. Let's first start by creating a helper class for our line segment. I don't want to put everything in the update and start functions because it's going to get messier. So let's start by creating a few constructors, and I obviously need a start and an end point for my line segment. And we'll need another constructor that takes in these two parameters that I just defined. Okay, let's define the variables here. And I'm also going to add a few helper functions that will be helpful for the coming tutorials. Yeah. So this function just basically sets the two endpoints. This is useful when you want to update the line just to visualize things. We obviously want to normalize the line to get the direction. Okay, so we'll have one other function that is going to draw this. So basically I'm going to demonstrate this using gizmos, but this can be extended to any game object without a problem. Start and end. Okay, so now that we created our little line segment class, let's start getting into the fun stuff. So I'm going to create two line segments that's going to be my initial line and the line that is going to be perpendicular to it. Okay, so now I have my start and my update functions, and I'll also need gizmos. On render gizmos. What is it called? draw gizmos. So here we'll be drawing our lines. So the parent line, I'm going to make it a green, and perpendicular line will be a red color. Okay. Okay, now let's expose the start and the end points of the line we're going to be drawing. I mean, yeah, the parent line that we want to draw. Start position, and I want to give it some default value. Okay. And the end position, I want to have it 5 units. Yeah, sounds good. And in start, I'm going to create a new line segment. And I'm going to pass in the start and the end position. And I'm also going to create a new perpendicular line, but I'm not going to initialize with anything, just give it a default constructor. All right. And yeah, there's also one more check I want to add. So by default, on draw gizmos even gets called when the application is not in the game mode. So adding this check will only make it run when the application is in the game mode. Okay. Yeah. So let's see if our line is being drawn. Over here. It's taking quite a while to load. All right. Let's hit that play button. There we go. We have our line, and we can change the start position. Oh, wait a minute, never mind. Oh, okay, that's because I haven't been updating it. Sorry, my bad. Okay, let's go back to Visual Studio now. Sorry that so this is the line I added before. I forgot to switch the window I'm recording. All right. Yeah, so this is the line I added. Okay, there is a very easy way to get a line perpendicular to this. That's using Unity's inbuilt function, which goes like this. Perpendicular line, it's vector 2 dot perpendicular, and we give in the direction. So we get the direction. Okay, so now we have the perpendicular direction, and So this is a unit vector. Now we need to draw it. We need to specify the start and the end positions of this. So now we just have the direction, but we don't know where it starts and where it's going to end. So let's do that. Okay, so I'm going to expose these for convenience sake. This is not the best way to do it, but yeah, for now let's just go with it. So the start, I'm going to set it to line dot start, and end will be line dot start plus perpendicular. There's probably a good way to name this, perpendicular direction. And let's give it 5 minutes. Yeah, why not? Okay, so this should generate our perpendicular line. Let's go back to Unity and see if it works. Alright, we got our perpendicular line here. So you can change this and it still stays, it's perpendicular to it. Yeah. Okay. Okay, that was easy, wasn't it? But the main reason I'm making this video is not to just use the helper function that Unity provided us with. I mean, it's great, but it doesn't hurt to know the underlying concept which makes this possible. I mean, so once you get this, you can extend it to create a vector at any angle you desire. So basically, in 2 dimensions, to rotate any vector, we need a rotation matrix. So it's a quite simple thing in 2 dimensions, and the rotation matrix goes as follows. It's cos theta, sine theta, and minus sine theta, cos theta. So we're going to be using this matrix to calculate a perpendicular vector to the given vector. So it goes like this. So you have x, y, and this is our given vector, and you have the rotation matrix. Suppose that's like a1, a2, a3, and a4. And now you do the matrix multiplication, and it goes like this: a1x plus a3y, and that's one element, and the second element is a2x plus a4y. So if this is our normal vector, and if we apply theta as 90 degrees, so we're rotating 90 degrees, and this will be the perpendicular vector that we so desperately want to get. Okay, let's go back into the code and try to get this done. All right. So the first thing we need is a way to store the matrix. So let's do it the quick way. Let's create a two-dimensional array, and let's get rid of this thing first. Yep, this is gone. So let's create a two-dimensional array that's called rotation matrix. And let's also store our angle. So let's make this public actually. Let's expose this. Alright. Okay. Now let's set up our rotation matrix. Rotation matrix 0, 0, 0 mathf.cos. Mathf.cos takes in radians, so to make it convenient for us, we are taking the angle in degrees and we are going to be converting that to radians here. Let's duplicate this. So 0, 1, 0, 1, 0, sine, that is cos. Okay, great. Now we have a rotation matrix. This is a 2D rotation matrix. This doesn't work for 3D things. This is only specifically for 2 dimensions because there is no Z component here. So it's just a 2 by 2 matrix. Now we have a rotation matrix, and now we have the direction of the original line. Now we need to just calculate the direction of the perpendicular. Let's just create the perpendicular direction first because we deleted it before. Perpendicular direction dot x into rotation matrix 0, 0. Okay, let's do the same for y. So x into 0, 1, and this will be 1 and 1. There you go, we have our perpendicular direction. So in 2 dimensions, this is as simple as it gets. Okay, so this is exactly what we did. We multiplied x with a and y with a3, so that gets our first the x of the perpendicular vector, and then x with a2 and y with a4, that gets the y of the perpendicular vector. Okay, let's hope this works. Let's go back to Unity. All right. Yes. So there you go. We have our vector. So uh, so I noticed that I made a small mistake here. So this should be cos theta sine theta, and this is minus sine theta and cos theta. Yeah. So according to this, yeah. So this is 0 0 0 1 1 0 and 1 1. Okay. So that's the reason it was inverted, and now we should be getting the proper vector. All right. Yeah, see, so we have a line segment and we have another line perpendicular to it, and everything is awesome. Okay, so now even if we change this angle, we won't see any change in the angle between the two line segments, because we're making a rotation matrix in start, and obviously it's not going to update every frame. So to demonstrate that, here we go. So I just moved the rotation matrix from start to update, so that in every frame it just checks the angle and regenerates the rotation matrix. Okay, let's go back to Unity and see how it works. Okay, let's give it 45. There we go. Let's give it 45. Okay. Minus 45 will be in clockwise direction. 45 is anti-clockwise. And even if we change the y position of the end vector, it still maintains that relative angle with this vector. So that is what we want. And yep, hopefully you learned something, and just yeah, hopefully you learned something. And if you have any recommendations for future videos, just leave them in the comment section. I'll be happy to make more videos on things related to math, physics, and something on AI. Yeah, so give a like. Thank you for bearing with me.